Hello students, welcome to today's chemistry class. My name is teacher Alice and I will be taking you through the third part of the topic salts. It is a Form 2 topic. We have looked at the first two parts. We looked at the definition of salts. We looked at the solubility of salts in water. We also looked at another subtopic, that is solubility of bases, and also we have also discussed the part of crystallization. So today we are going to look at the methods of preparation of salts, and we are first going to start with the first method of salt preparation, which is action of acids on metals. So how do we react, or which metals do we react with acids to give us a salt? So let me take you back to the Form 1 topic, the acid, bases and indicators. We looked at the properties of acids, where we reacted the acids with metals, acids with bases, acids. So all these reactions were giving us a salt. So if we need to prepare a salt, then we can react an acid and a metal. That one will give us a salt and also hydrogen gas. So we need to ask ourselves, what are the factors we need to look into when we are reacting the acid and a metal with the intention of getting a salt? So the first factor is that the metal we choose should be above hydrogen in the reactivity series. So you must know the reactivity series so that you know the metals that can be reacted with acids to give us metals. So all those metals that are above hydrogen gas, including zinc, lead, magnesium, calcium, all those metals can be reacted with an acid to give us a soluble salt. Metals below hydrogen gas, that is the copper, silver, gold, they do not react with dilute acids. Therefore, we cannot form a salt of copper, a salt of silver, a salt of gold by reacting it with an acid. So only those metals that are above hydrogen gas that can be used to prepare a salt by reacting it with an acid. The second factor we look at is the metal chosen should not be too reactive. The most reactive metals like potassium and sodium, they cannot be reacted with dilute acids. It is not safe because they react explosively with dilute acids. So those are the two factors that determine whether we can prepare a salt using those metals. So we have an experiment here and a procedure that describes the steps on how to prepare zinc sulfate crystals, starting with zinc metal. So as we have said, zinc metal is above hydrogen gas in the reactivity series. Therefore, we can react it with the corresponding acid to give us zinc sulfate. So if we need to get the zinc sulfate, we are going to use sulfuric 6 acid. So we react zinc plus sulfuric 6 acid to give us zinc sulfate. So this is the procedure, starting with the procedure number 1 or step number 1. We add zinc metal in excess. So we add zinc metal to sulfuric 6 acid, not vice versa. So when we add zinc in excess, this one will ensure that all the sulfuric 6 acid has reacted. Process number 2, we are going to filter off the excess zinc metal. So the excess zinc we have used, now we are filtering it so that we are left with zinc 2 sulfate solution. So excess zinc metal will be the residue, and now the copper 2 sulfate solution will be the filtrate. Now we heat the zinc 2 sulfate solution to saturation. So we want the zinc sulfate as crystals. So step 3, 4, and 5, these are steps of obtaining crystals. So after we heat it to saturation, we cool the saturated solution to form crystals. So note, when we are heating the zinc 2 sulfate solution, we do not heat it directly, but we use we use a water bath. Then we cool the saturated solution to form crystals. And then the last step here, we filter off the crystals, dry them between the filter paper. So we ensure we give the solution to cool some hours so that it forms larger crystals. Step number 5, we filter. So we filter the crystals and then we dry between the filter papers. That is how we can obtain zinc sulfate as crystals. So ensure you look at what we have been asked, whether we have been asked to start with what. So this one, for this question, we have been given zinc metal. So this one determines what you are going to react with to give you the salt. So starting with zinc metal. So here, definitely we know that we are going to react an acid and a metal. Those other salts that can be prepared the same way are, for example, magnesium sulfate, calcium chloride, calcium nitrate, zinc nitrate. All these salts can be formed by reacting the metal with the corresponding acid. So that is the first method of salt preparation. We look at step number 2, or the method number 2, reaction between acids and bases. So here we are going to look at the metal oxide. So the metal oxide and the metal hydroxides are bases. So when we react an acid and a base, the products are salt and water only. We gave a name to this reaction and we called it a neutralization reaction. So we react an acid plus a base to give us salt and water. There is an envy that says this method can be used to prepare salts of metals that are too reactive or metals that are below hydrogen in the reactivity series. So this is the opposite of the first method. We said the first method, where we are reacting a metal and an acid, we do not use those metals that are too reactive or those metals that are below hydrogen in the reactivity series. So you can see for the second method, we can now prepare salts by reacting the most reactive metals and also those metals that are below hydrogen in the reactivity series with acids. For metals that are too reactive or below hydrogen in the reactivity series, the metal is first roasted in air to convert it to its oxide. So you cannot react the metal directly, so you have to roast it. That is adding oxygen, so that you get the oxide of that metal. Then the oxide now reacts with the acid to give us the salt. Okay, we look at an experiment for preparation of copper sulfate crystals, starting with copper metal. We said you first roast. So you roast copper metal to form copper oxide. Step number 2, add copper 2 oxide in excess to dilute sulfuric 6 acid. This one will give you copper 2 sulfate solution. Step number 3, we filter off excess copper 2 oxide to obtain copper 2 sulfate. So this one is also like a repetition of the first method, the procedure. So step number 3, number 4, and number 5, it is like a repetition. Just now we replace with copper 2 oxide, or we replace by the base and the acid. So filter off the excess copper 2 oxide to obtain copper 2 sulfate as the filtrate, and now the copper 2 oxide, the excess copper 2 oxide as the residue. Step number 4, heat the solution to saturation. Now we want to get the crystals. We cool to form crystals, and the last step, we filter off the crystals and dry between filter papers. So that is the experiment to obtain a sort of copper sulfate, which is a reaction between a base and an acid. Other examples of salts that can be formed using the same process are zinc nitrate, magnesium chloride, all those salts. We look at method number 3. Method number 3 involves the reaction between acids on carbonate and hydrogen carbonates. So this one is also another property of acids. So acids react with carbonates and hydrogen carbonates to give 3 products: salts, water, and carbon dioxide, both the carbonates and the hydrogen carbonates. An experiment here, we are to describe the procedure of preparing lead nitrate, starting with adenine lead carbonate. So here you have to know what the starting point. So you have to react the carbonate with an acid, and now if we want the nitrate, the lead nitrate, and you have the lead carbonate, definitely you are going to react the carbonate with a nitrate. So this one will be a form of a precipitation reaction. So this one, we have the procedure here. Step number 1, add excess lead carbonate. So we are always using excess to an acid. Whatever we are using, be it a carbonate, be it a base, be it a metal, we need to use it in excess to ensure that all the acid has reacted. So when we react lead carbonate and nitric 5 acid, we are going to get lead nitrate, water, and carbon dioxide. Lead nitrate is soluble in water, so we are going to filter off the excess lead carbonate. So we are going to obtain lead carbonate as the residue and lead nitrate as the filtrate. Step number 3, this one is to obtain the crystals again. Heat the solution to saturation and cool the saturated solution to form crystals. The final step, filter off the lead nitrate crystals and let the crystals dry between filter papers. So this is the process or the procedure on how to obtain a salt from the carbonates. Other examples are, for example, calcium chloride can be obtained by a reaction between calcium carbonate and hydrochloric acid. We look at the 4th method of salt preparation, that is direct synthesis. So this one can be used to prepare basic salts and also the normal salts. It involves just the combination of elements, reacting a metal with an nonmetal. For example, if we want to obtain sodium chloride, we just need to react sodium metal and chlorine gas. So when we react the two, that is, we lower burning sodium metal in a gas jar that has chlorine gas, the reaction will give us what? A white powder, which is sodium chloride. So this one is just the combination of 2 elements, a metal and a nonmetal, to give us a salt. that method is known as direct synthesis. So those are 4 methods of preparation of soluble salts. There is a question here and a takeaway assignment. Describe the procedure of preparing lead nitrate, starting with lead metal. Use the equations where necessary. So look at that question and try answering it. The chemical equations should be well written and should be well balanced. So thank you. Let us meet for the third part of this topic, the method of preparation of insoluble salts. Till we meet again, goodbye.